Alright, so this is the Unit 3 Lesson 5 video on completing the square. Completing the square is another method to solve quadratics. It's the last one we're going to look at in this unit. So we looked at solving by graphing, solving by factoring, and the quadratic formula. So completing the square is an alternative to all of those, and it's my favorite method. Alright, so when a quadratic cannot be factored, then the quadratic can either be solved by the quadratic formula, which we did in the last lesson, or by this method of completing the square. Alright, so some vocab, some looking at where this completing the square comes from. 25 is a perfect square. Alright, the number 25 is called a perfect square. And it's a perfect square because two of its factors, the two numbers that multiply to be 25, are the same, 5 and 5. In the same fashion, x squared plus 6x plus 9 is called a perfect square trinomial. Now, it's a trinomial because there are three terms, 1, 2, 3, in the polynomial. And it's a perfect square because when we factor it, it factors into x plus 3 times x plus 3, and each of those factors are the same. All right, so the reason we're talking about perfect squares is because when we complete the square, we're going to be using numbers like 25, 36, 49, those perfect squares, in order to achieve the solution we want. So what we do in this method is we rewrite the equation in a way that works for us. So we actually manipulate the terms to get what we want. Now here's what we're going to do in A, B, and C here. We're going to fill in a value for C, which is the constant of each of these trinomials, so that the trinomials are perfect squares. Okay, so the way we're going to do this is we're going to take half of the middle number. I'm going to abbreviate here, and that middle number is your b term. Remember, a quadratic is in the form ax squared plus bx plus c, so b is the middle number there. So we're going to take half of that middle number and square it. Okay, so here's how this is going to look. For the first one, x squared plus 10x plus c, I'm going to take half of this middle number, half of 10, 10 divided by 2, and I'm going to square that value. So half of 10 is 5, and 5 squared is 25. So 25 is the new value of c. So if I wanted to rewrite this here, I'd have x squared plus 10x plus 25. That is our fully factored form. Now let's factor this really quick, because that's what it said to do. Factor the trinomial. I want to see what happens. So when I factor by split the middle, I'll have 1 times 25, which is 25. And I need two numbers that multiply to 25 and add to 10. Well, that would be 5 and 5. So splitting the middle here, I'll have x squared plus 5x plus 5x plus 25. And we're going to group. From this first group, I pull out an x, and I get x plus 5. And the second group, I can divide out a positive 5. And I'll get x plus 5 again. So when I factor this, it looks like I get x plus 5 times x plus 5, which is what we wanted to achieve. Remember, we wanted two factors that looked exactly the same. All right, so we'll do B. I think we'll not do C, which is fine. No worries. But we'll do B at least, so we can make sure we see this again. So remember, in order to find C, we take half of the middle number and square it. So that gives me negative 4 squared, which is positive 16. Remember, whenever you put a negative to be squared, you put it in parentheses and square it. Any number times itself is positive. Well, let's take the long way to factor this again. We'll have y squared minus 8y plus 16. And I want to find two numbers that multiply to 16 and add to negative 8. that would be -4 and -4. Now the long way to split the middle here would be y squared minus 4y minus 4y plus 16. And we group those two. From the first group, we pull out a y and get y minus 4. And this term is negative, so I pull out a -4 here and get y minus 4 again. Your final answer takes y minus 4 times y minus 4. And again, in both of these, notice that we have a perfect square trinomial. We have two terms that are the same multiplied together. Well, here's one thing I want you to notice when we factor here. Right? I'm going to write it underneath the line, but you can write it on the line. Each binomial is the same. Alright, so that's what I mean there, is that I have x plus 5 times x plus 5. Each of those is the same. Y minus 4 times y minus 4. And the number in each binomial is half of the middle term. Remember, the middle term is your b. So notice here, b up in this problem on here is -8. Half of -8 is -4. That's what I have. Half of the first b is 10, or 10 is the first b. Half of that is 5, which is what I have here. So something to ponder as we get a little farther along. All right, so let's actually complete the square. I have some steps here. Most important thing to know about completing the square is that the a term, a, remember when I have a quadratic, it's set up like this. A is the first number in front of the x squared. So that number needs to be 1. If it's not 1, I'll tell you what to do when we get to a problem like that. So, first example, it says solve the following by complete the square. So I have x squared plus 8x plus 3 equals 0. We want to make sure that all quadratics are set equal to 0 when we solve them. Notice here that x squared does have a coefficient of 1, so we are allowed to use this method. All right, so we can skip right down to number 2. It says rewrite the equation. Now that looks complicated and mathy when I say x squared plus bx equals c. What that means is you're going to move the constant to the other side. But don't go so fast. I want you to write exactly what I write here. X squared plus 8x. Now, in place of that 3 that we moved, I want you to do plus a box. We're going to fill in the box in a minute. Equals, well, now I moved this -3 over, and I want you to put plus a box on the right side. If I put a box on one side, I have to put a box on the other side. That's called balancing the equation. Now we need to figure out what's going to go in that box. And what goes in that box is step 3 here. B over 2 squared. Now b is that middle number, 8. So I'm going to take 8 divided by 2 squared. This is exactly what we did back here to find the value of c. We took half of the middle number and squared it. This is c we're trying to find. So 8 divided by 2 is 4, and 4 squared is 16. And you're going to put 16 in both boxes. If I add 16 to the left, I have to add it to the right. Now, what we've done here is we have created a trinomial on the left-hand side that's going to factor really nicely for us. So that's what step 4 is, to factor that trinomial. So up here, we're going to do a shortcut starting in the next problem. But for here, I'm going to do it the long way. I need to find two numbers that multiply to 16 and add to 8. That would be 4 and 4. So when you factor the left-hand side here, you're going to get x squared plus 4x plus 4x plus 16 equals, now the right-hand side here, adds up to be 13. So simplify that. Now we're going to factor by splitting the middle. So we're going to put the first two terms in a set of parentheses and the last two. Now the GCF of the first terms, or the first set of parentheses is an x. So I pull an x out, and I'll get x plus 4. In this guy, I can pull a 4 out again. So I'll have x plus 4 here equals 13. And the factored form is x plus 4 times x plus 4 equals 13. Now, the thing that we're going to do is we're trying to solve. We're trying to get what x equals. One thing that we haven't done yet today, but we are going to do now, is that when these are the same, we can rewrite this as x plus 4, the quantity squared, equals 13. So whenever we have two of the same things, we can write it as a square. Well, this actually helps us solve the quadratic because I can now take the square root of both sides, which gives me x plus 4 equals plus or minus the square root of 13. You always need a plus or minus in front of the square root. And then all I do to solve for x is to subtract 4. Now when I subtract 4 from the right side, I'm going to squeeze it right in front of the plus or minus. So my final answer is going to be negative 4 plus or minus radical 13. And that's actually as simplified as we can get. Kind of like with the quadratic formula, sometimes you have irrational values. This is irrational. We could not have factored it, but solving by completing the square worked out for us. All right, so I know that seemed like a really long process here, but the long part came with the factoring. All of this right here, that was the long part. I'm going to show you a shortcut in the next example that's going to make it a little bit faster. So I have x squared minus 10x plus 30 this time. I have a 1 in front. So I'm going to, I can use complete the square. So remember, the first step in complete the square is to move the constant. We're going to subtract 30 from both sides. When I subtract 30, I'm going to write this as x squared minus 10x. And remember, once I move that number, I'm going to put a plus a box on the left. And then the right is going to be minus 30 plus a box. To fill in the box, we take half of this middle term. So half of negative 10, and we're going to square it. So negative 10 divided by 2 is negative 5 squared, and negative 5 squared is 25. So I'm going to fill a 25 into both boxes. Now, here's the factoring part. And I want to go back really quick to something that we should start to notice, because it's going to make the shortcut here really fast. On this last problem, when I ended up being in my factored form, notice that my factored form was x plus 4 times x plus 4. And 4 is half of the middle term. In the previous problem, we did talk about this, but in part A up here, we had x plus 5 and x plus 5. 5 is half of 10. So it looks like, just like we said here, the number in each binomial is half of the middle term. So when I factor here, I'm going to get two factors that look the same, and it's going to have half of the middle term. Half of negative 10 is negative 5, so this factor says x minus 5 times x minus 5. And then here, if I add up on the right-hand side, negative 30 plus 25 is negative 5. Now, if you don't trust me, you can FOIL this out. You can double distribute and check x squared minus 5x minus 5x plus 25, but it does work. Now, we're almost done then. We factored, so we're going to condense these factors together. X minus 5 squared equals negative 5, and we condense them because that way we can solve for x. To get rid of this square, we take the square root, which gives me x minus 5 equals plus or minus the square root of negative 5. Now pause here. When I take the square root of a negative, remember, I need to think about I. Remember, the square root of negative 5 is the square root of negative 1 times the square root of 5, which is I radical 5. So I actually want you to rewrite this. So we'll have x minus 5 equals plus or minus I radical 5. And all we have to do is add 5 to both sides. Remember, that squeezes in right in front of the plus or minus. So your final answer is x equals 5 plus or minus I radical 5. And then you are done. All right, let's try number 3. Number 3 has 3x squared minus 8x plus 4 equals 4x minus 2. Now, a couple things here. First, in order to solve a quadratic or to complete the square, you have to have the quadratic set equal to 0. So the first thing you have to do is move the 4x and the 2. So I'm going to subtract 4x and add 2 to both sides. Because then on the right, those are going to subtract off to get you 0. So I have 3x squared minus 12x plus 6 equals 0. So at least now we're set up to solve a quadratic because we're set equal to 0. The next thing we have to watch for here is that the leading coefficient this time is 3. And we want the leading coefficient to be a 1. So in this unit, what we're going to do is we're going to divide every term by 3. Okay? What that gives me then is x squared, remember there's an invisible 1 now, so that's good, minus 4x plus 2 equals 0. And that's good because now I have a 1 in front and I can do complete the square just like the last couple problems. So that's the only difference here is you have to divide by that leading coefficient. All right, to complete the square, you're going to move the 2 to start and fill in your boxes. So I'll have x squared minus 4x plus a box equals negative 2 plus box. In that box, you take half of the middle term, so negative 4 over 2 squared. Half of negative 4 is negative 2, and negative 2 squared is 4, positive 4. So I put a positive 4 in both boxes. Now to simplify this, remember we're going to do a shortcut of factoring here. To factor the left-hand side, they're going to be a perfect square trinomial. So each factor is the same, and I'm going to take half of the middle term to go in my parentheses. So half of negative 4 is negative 2. And then on the right-hand side, negative 2 plus 4 is positive 2. And now we condense the left, x minus 2 squared equals 2. You square root and move the term and you're all set. Whoop, wrong one, sorry, wrong button. So I take the square root. I get x minus 2 equals plus or minus radical 2, and square root of 2 does not break down. So all you have left to do is to add 2 to both sides. Remember, that's going to squeeze right in front here. And you're left with x equals 2 plus or minus radical 2. And you're all set. All right. I'm actually going to skip number 4, and I'll start it. I'm not going to do the whole thing. Okay, so number 4, if I wanted to complete the square, to start, because there's a 3 as the leading coefficient, I would have to divide every term by 3. So if I do that to start, I get x squared plus 5 over 3x plus 2 equals 0. So first of all, I have a fraction which doesn't look really friendly. It's kind of yucky. So let's do another step or so, and then we'll see where we get. I'm going to subtract 2 from both sides. So I would take x squared plus 5 over 3x plus our box equals negative 2 plus my box. Now here's where the yucky problem part starts. To fill in the box, I would have to take half of this number. So I'd end up doing 5 over 3 divided by 2 squared. And that just doesn't look nice. So that's the reason we're actually going to stop. And I'll give you a hint why. When the middle term is either a fraction or it's odd, right? 5 is an odd number. Complete the square is not really going to work for us, especially once I divide and I get 1x squared. If I have a fraction or an odd number in the middle still, even after I divided, complete the square is not going to be the best method, and you're going to end up wanting to do the quadratic formula like we did in the last couple lessons. Okay, so what I'm going to have you do now is we're going to stop this one. I want you to do the 2 problems on the bottom of the page. The solutions are there. There's also going to be a video posted on Canvas, but you really need to try these 2 before you can move on. Completing the square is really simple, but you have to do it a few times in order to remember the steps.